Hello everyone, this is Deep Doshi, and this today we are going to solve another important problem uh, from the point of view of interviews. But the problem is spiral matrix. Now, given a matrix, you are supposed to print the elements, or you are supposed to return the elements in spiral order. So, for example, if you have this particular matrix, you want to print 1, you want to print a 2, you want to print a 3, then a 6, and then a 9, then 8, then 7, then 4, and then a 5. So you want to go in this direction, which is spiral in nature. So you want to go with the outer loop, then the inner loops, and then keep on going in that fashion. So, what should be the approach? It was a little difficult because for me, I was particularly thinking about traversing the matrix, swapping the elements, or something doing like that. But the idea was even simpler than this. The idea was having a pointer. So I knew that when I traverse, initially I will go 1, then I'll go 2, and then I'll go 3. When I traverse the first row, I do not need to come back to that row. So the new matrix should be this. That's it. When I traverse these numbers 3, 6, and 9, I know that I just am supposed to now look at this 4, 5. I am just supposed to look at this particular 4, 5, 7, 8. So 4, 5, 7, 8. That's the matrix I am supposed to look at. Then I will traverse this way. Then I am just supposed to look at these matrices. So all of these gave me a hint that I will have 4 variables here for the 4 different directions of a matrix. So for example, the top, the top, I'll just put this. The top over here will always denote the top. Yeah. So the top will denote the first. The top will denote the first row of the matrix that I'm looking for. The bottom will denote the bottommost row. There would be a left pointer and a left right pointer. So left pointer would be here initially, and the right pointer would be here initially. First, this is here somewhere. Yeah. So I will initialize these pointers, and left pointer will keep a track of the leftmost column. Right pointer will keep a track of the rightmost column of the matrix. Top will keep a track of the topmost row. Bottom will keep track of the bottommost row. So now what I will do is, initially I would say that I want to move in the right direction, towards the right. So I will call another variable. There is another variable called as direction, and there are 4 directions I move in. That is right, bottom, left, up. Yeah, these are the 4 directions that I will move in, right? So I am initializing a variable direction to be 0. Now, when the direction variable is 0, I know I move to the right. So initially, anyways, I'm going to move to the right. So I initialize it to 0. Yeah. Okay, I move to the right. Now 1, 2, and 3 have been put inside my answer vector. So 1, 2, and 3. The moment I reach this particular point, I need to traverse down. So the moment I reach this point, I would say top has to be incremented by 1. So now the new top becomes this. This is my new top. So top is now pointing to this particular thing. Now this is the matrix. The new direction would be equal to 1. Since the direction is equal to 1, what I need to do for direction 1, I need to go down. So I need to keep my row same, or no, I do not keep my row same. I have to go from, for I is equal to top to bottom. Okay, I am changing my row. I would print matrix of matrix, whatever matrix has. I would print the I, that is the row, and R is still the same. After going down, what happens is R changes. R goes -1. And what happens to the direction? The direction becomes left. So left is 2. Now what happens for what happens now? R has come here. R has come here. 8 comes here. What happens now? For I would be equal to, from the right to left. Okay, of course I'm just writing right to left. You will have to write the conditions. Right to the left. What I will do is, I need to keep the row same. I need to change my column, so I will keep decrementing my rights. So I would print what I would have to print matrix. I keep the bottom as it is, and the column is changing. So the column becomes I print, and after that the direction, after this loop, of course, after this loop, it's not in the loop, the direction now becomes upwards, so it's 3. And what happens, since this is covered, what happens to the bottom goes up by 1. So bottom comes here, bottom comes here, bottom also comes here, top is also here, top is also here. This I can move it here. So bottom and top are here, left and right are here. Now I need to move, direction is 3. So direction is 3. So say I would have to move upwards by 1. So from bottom to top, I would move. So for I would be equal to, from my bottom to my top, I would move. I would move such that bottom to the top, I'll have to move. Bottom to top, I'll have to move. So it's almost equal. So I would just, what happens is what changes, it's the row that is changing. So I would print matrix of what I, that is my row, and it's the column that is changing. Sorry, row is changing, so that is matrix of I. Since I am having at the left, so I will keep the left as it is, and I will go upwards. Then I need to move to the right, so I direction is equal to 0, because I moved up. To what happens to the bottom? Since I moved up, what happens to the bottom? Wait. What happens to the bottom when I move up? When I move up, what happens to the bottom? The bottom decrements by 1. So bottom is decrementing by 1 here. It's going from right to the left. So it goes here. Yeah. When I move here, I need to go right. So left is incremented by 1. Left is incremented by 1. So your left is incremented by 1. Yeah. So this is how we solve it. So we'll walk through the pseudocode once. So I have my answer variable. This answer, it's a vector, so it's just my output. If the matrix size is equal to 0, I just return my answer. Is a trivial case that we need to handle, the test case. The top is equal to 0 initially. The bottom is pointing at the bottom most. The left is pointing to the leftmost column right is pointing to the rightmost column, the direction is equal to 0, which means that initially I am going to move to the right. While top is less than equal to the bottom, of course, for a matrix to be a valid matrix, top has to be lesser than the bottom. And for a matrix to be a valid matrix, left and right, the left has to be less and right has to be greater. So that's a normal trivial condition. If the direction is equal to 0, that means I want to move from left to right. So for integer I is equal to left, I is lesser than the right, I will keep moving to the right. I will push back, the top is the same, the column is changing, so top and I push it back, I increment the top, so the top comes down, the direction now becomes 1. What does direction 1 mean? Direction 1 means I'm going to go down. So from top to bottom I'll move. Since I'm changing my rows, this matrix of I and matrix of right, I'm pushing it back because I'm in the rightmost. Then I decrement the right and I make the direction as 2. Direction as 2 means I'm going to move to the left. Now from right to left, I keep decrementing my pointer from right to left. I will print the, what happens, the row is the same, row is the bottommost row, and what is the column? Column is my I, right to left. So I move here, bottom minus minus means bottom comes here, and direction becomes equal to 3. The next loop, direction is equal to 3. I'll go from bottom to top and make direction equal to 0, left is plus plus, and so on. So this is how it will go. And if we want, we can walk through it. Yeah, we just walked through the code. Yeah, so that's it for today, guys. I'm not sure if the video was good enough or not, but this is how the approach is, and I hope you like this video.